welcome to our channel. Today we're going to talk about linear programming using graphical method. In linear programming models, there is a function called an objective function, which is to be maximized or minimized while satisfying several conditions or constraints. Graphical method is limited to linear programming models containing only two decision variables. Graphical method provides a visual representation of how a solution for a linear programming problem is solved. The steps on solving linear programming using graphical method will be presented through the problems. A furniture company makes bookshelves and desks. Each shelf requires 2 hours for carpentry work and 1 hour for painting. Each desk requires 3 hours for carpentry and 4 hours for painting. The company has a maximum of 60 hours of carpentry work and 40 hours of painting available each week, and they make a profit of $15 per shelf and $40 per desk. How many shelves and how many desks should they make?
So this is the tabulated form from the given, and for our decision variables, we have x be equal to shelves and y equal to desk. Objective function, let's make a profit equation. The profit the company makes will be equal to $15 times the number of shelves, which is our x, plus $40 times the number of desks, which is our y. For the constraints, let's take the information in the table and make some inequalities. For our first constraint, in terms of carpentry time, if the shelves takes 2 hours, so the total shelves that they make will be 2 times x, or 2 hours times the number of shelves. So when they make a desk, that's going to be 3 times y, or 3 times the number of desks that has to be less than or equal to 60 hours. Same as it goes for painting, it will be 1 times x plus 4y less than or equal to 40. Obviously, they can't make a negative number of shelves or desks, so that means x has to be greater than or equal to 0, same as for our y, that has to be greater than or equal to 0. So let's figure out the x and y intercepts of each constraint. For y-intercept, it is going to happen when x is 0, so we let x equal 0 and it will result to y equals 20. Same as for our x-intercept, it is going to happen when y is 0, so let y equal to 0 and it will result to x equal to 40. For our second constraint, we let x equal to 0 to look for our y-intercept. On the other hand, we let y equal to 0 to look for our x-intercept. The graph is going to be just in the first quadrant. We plot the coordinates that we have just solved, so let's shade underneath of our straight line that indicates it is less than or equal to. This serves as our inequality. Now for the feasible region, the area shaded with the marker, as you can see, is the part where we have both constraints region meets. The next thing to do is to find all the corner points. We know 3 of them, and we know its origin, which are 0, 10, 30, 0, and 0, 0. What we want to find is the last corner point where the two lines intersect. So to do that, I'll take both of our constraints and solve them to find x and y. I'll do that by multiplying the second equation by -2 and add the two equations together. So I get y equals 4. By plugging y equal to 4 in our second constraint, we'll find out what is x, which is x equals to 24. Since I now have the last corner point, so now we can figure out how the company will make the most profit. By plugging in each corner point in our objective function, we now get these results. Since we maximize the profit, the best thing that they can do is to make 24 shelves and 4 desks each week. That provides a profit of $520. So this will be our optimal solution.
A rancher is mixing 2 types of food, brand X and brand Y, for his cattle. If each serving is required to have 60 grams of protein and 30 grams of fat, where brand X has 15 grams of protein and 10 grams of fat and costs 80 cents per unit, brand Y contains 20 grams of protein and 5 grams of fat and costs 50 cents per unit. How much of each type should be used to minimize cost to the rancher?
try to minimize the cost of the rancher. So this is the tabular form, and we let x is equal to brand x and y is equal to brand y. To obtain the optimal function, we know that for brand x would cost 80 cents and for brand y would cost 50 cents. So z would be equal to 0.8x plus 0.5y. So for the constraints, we let x and y be greater than or equal to 0, since we talked about the cost and cost cannot be negative. For the protein and fat constraints, 15x plus 20y would be greater than or equal to 60 for the protein, and 10x plus 5y would be greater than or equal to 30. For the equations 15x plus 20y is equal to 60 and 10x plus 5y is equal to 30, we get the points by getting the x and y intercept, where x would be equal to 0 and y would equal to 0. If x is 0, y would be equal to 3, and if y is 0, x will be equal to 4. For the equation 10x plus 5y is equal to 30, we get their x and y intercept as well. So if x be equal to 0, y would result to 6, and if y is 0, x would result to 3. For the equations 15x plus 20y is equal to 60 and 10x plus 5y is equal to 30, we get the points by getting the x and y intercept, where x would be equal to 0 and y would equal to 0. If x is 0, y would be equal to 3, and if y is 0, x will be equal to 4. For the equation 10x plus 5y is equal to 30, we get their x and y intercept as well. So if x would be equal to 0, y would result to 6, and if y is 0, x would result to 3. So we then plot the points for equation 15x plus 20y is equal to 60. So we obtain the points 0, 3, and 4, 0. Now for the equation 10x plus 5y is equal to 30, we will now plot the points 0, 6, and 3, 0. Going back to our optimal function z is equal to 0.8x plus 0.5y, we will try to substitute the points 0, 6, 4, 0, and 2.4 and 1.2. First, we will substitute the point 0, 6 to our optimal function and will give z is equal to 3. Now for the second point 4, 0, we will also substitute it to our optimal function and will give a result of z is equal to 3.2. Lastly, to the points 2.4 and 1.2, we will also substitute it to our optimal function and will give a result of 2.52. We will now compare results for point 06, 40, 2.4, and 1.2. Now the smallest value is z is equal to 2.52, which will be our minimum cost since it has the least value.
That's all for this video. Thank you so much for watching. Don't forget to like and subscribe. Till next time!